All right, so in this one, we're going to talk about the trapezoidal method, which is actually 5.5 in your book. So remember, the formula for the area of a trapezoid is going to be 1/2 times the height times base 1 plus base 2. Now the height is always going to be the one vertical piece, and then base 1 and base 2 are on the tops and the bottoms. Now when we're looking at this on a graph and what that's actually going to be, right? This is going to be f of x at that point. So maybe it's f of 1 and this is f of 2, but this is still f of x at that point, whatever point it is. That's where we're getting base 1 and base 2. And the height is going to be the width of your trapezoids at the bottom. So when we're thinking about it on a graph, right, so say we've got a graph like this, and we've drawn in our trapezoids, right? The height is this piece down here at the bottom, okay? Now, the formula that your book uses is kind of confusing, but this is how you'll see it in your book. Area is equal to b minus a over 2n, where b minus a over 2n is really just standing for the number of partitions or the height of your trapezoid. So don't stress about what you're seeing there, just find the height from your subintervals, okay? So here we're going to use the trapezoidal method with n equaling 3. So we want to create 3 trapezoids, okay, to approximate area under the curve for 2x squared minus x from 1 to 4. So the first thing I like to decide is what my height is going to be. And the way I do that is I look at my numbers, right? From 1 to 4 is actually spaced out into 3. So that's actually really nice because we've got a 1 to 4 is 3 spaces, and if you divide by the number of pieces you have, which is 3, we get 1. So we know our height is going to equal 1. Right? If you just do 4 minus 1 over 3, that's the a and the b minus the n. That's where we're getting our subintervals from. So our height is going to equal 1. So let's look at our trapezoids. We've got our first one here. And then the second one. Sorry, I'm not great at drawing straight lines. Been working on it, still not getting any better. All right, so there's our 3 trapezoids. It's going to be 1, 2, and 3. We know the widths down here at the bottom are indeed 1 each piece, right? There's 1 gap. So let's look at our first trapezoid. The first one, our area is going to equal 1/2 times our height, which is 1, times base 1 plus base 2, which is really f of 1, because we're starting at 1 there, f of 1 plus f of 2. All right, so now let's find that area. We've got area equals 1/2. 1/2 times 1 is just 1/2. I'm going to put these in brackets to make them stand out a little bit more here. F of 1 looks to be about 1 plus f of 2, which looks to be about 6. So we get the area equals 1/2 of 7, or 7/2. All right, let's check out trapezoid number 2. Our area is going to equal 1/2 times 1. That part doesn't change. But we'll have f of 2 plus f of 3. So we've got 1/2 of 6 plus 15. Again, I'm just pulling those from the chart or from the graph itself. So then that's an area of 21/2. And for the third trapezoid, we've got area equals 1/2 of 1 times f of 3 plus f of 4. All right, so that's going to be 1/2 times 15 plus 28. Which gives us 43/2. And just like the rectangles, we're going to add them all together to get our total. So we've got 7/2 plus 21/2 plus 43/2, which gives us 71/2 units squared. All right, the last example we're going to look at today is going to be one where we have a chart. So we've got a car computer records a digital readout of the fuel consumption in gallons per hour. During a trip, a passenger records the rate at which the fuel consumption every 5 minutes for 30 minutes. So here is our interval. Okay, they told us 5. And then we want to use the table below and use the trapezoidal method to approximate the fuel over the 30 minutes. So our h, right, is going to be the 5 that is in between each one. So those are each one of my trapezoids. Okay, I'm going to split them up as best I can so that you guys can see them in separate pieces. But it really, you can really just write it as one line. So we're going to have 1/2. Again, the height here is 5. Now, because we're using this for all of them, we can really just leave this out in front of everything if we wanted to. I'm going to write them separate so that you can see it, and I'll show you what I mean by write it out in front of everything. So we've got 1/2 of 5, and then we're going to have our first 2 points. So 0.07 plus 0.08, because those are our bases. And then we're going to add another piece. So I'll change the color so you can see I'm changing pieces. It's still going to have that 1/2 in the 5. But now we're going to use 0.08 plus 0.09. Okay, then another piece. I'll change colors again. Still got the 1/2 in 5. But this time we'll have 0.09 plus 0.1. All right, then we've got plus 1/2 times 5, and then in parentheses 0.1 plus 0.12. All right, and change color again, plus 1/2 times 5 times 0.12 plus 0.13. All right, plus 1/2 times 5 times 0.13 plus 0.11. All right, let me make sure I have all my subintervals. I got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then at this point, we can calculate it in our calculators. I'm going to calculate each piece so that you guys can see that, but you could just type it all in as one. When you type it all in as one, please be careful. You could make an error at typing things in. So when we type in the first part, we get 0.375 plus 0.425 plus 0.475 plus 0.55 plus 0.625 plus 0.6. Okay, and then I would just type all those in, and we would find that the total consumption is 3.05, and we're talking about gallons, right? Because we're taking the area underneath the curve of gallons per hour. So we're taking out that per hour and left with gallons. If you have any questions, please make sure you ask them the next time you see me in class.